So we want to do number 39 and 11.7.
I'm trying.
The moral of which is, yeah, always freeze your murder victims. Okay? So they told us that the coroner found the room temperature to be 22 degrees. The victim's temperature was 29 degrees. The normal temperature of what? Of live people.
The live, yeah, of the live body.
Right? The normal temperature of dead people is room temperature. The normal temperature for live people is the one that matters, right? That's where they started. So that's 37 degrees. And then they give us this constant K.
Okay, log roll.
And then before all this jazz, they tell us to use this formula, right? Which says that time is K times the natural log of this whole quantity B minus R over B0 minus R. And then they give me what all those variables mean, right? K is a constant, T is time, R is room temperature, B is body temperature, B0 is original body temperature. And this should amount to just matching.
Oh, maybe.
Okay? So what am I looking for? What's the one of these that I'm looking for?
Time.
Yeah, I'm looking for time, right?
Yeah.
So I'm not going to fill in a number for time, but I should hopefully be able to fill in numbers for all the others. So what corresponds to K the constant?
Negative 3.8.
Yeah, the K they gave me, right? So this guy matches that guy, right? What's the room temp?
22 degrees Celsius.
Okay, so this guy here is going to go in for R. Then which one's the body temp and which one's the original body temp?
The body temp is the victim temperature.
Yeah.
This guy, the victim temperature, right, is body temp, and the original body temp is this 37 degrees. You guys all see that? And then this is literally as simple as plugging this jazz in.
I'm gonna try this.
Right, so T is, what's your K?
Negative 3.0.
Minus 3.8065. And then what are you supposed to do with that? You're supposed to multiply by the natural log of, and then fill this stuff in. So what's B?
29.
B is 29
Minus 22.
minus 22 divided by
37.
37 minus 22. And then what do you do with this? Do you need to solve or? Yeah, this is an evaluate, right? We got to do this stuff in the grouping symbol first. Okay, so we're going to get minus 3.8065 times the log of 7 over 15.
What does it say in the back of the book?
Okay, so log 7 minus log 15? Sure. Yeah, you could rearrange this. You're going to shove this in a calculator anyway, right? Oh, yeah. So this is as far as you're going to get by hand. Right? So, bam, answer by hand. If you want an approximation, which really is a good place to go because really all this is going to be as an approximation anyway, right? You guys all see that? Right? Like, really, I don't expect that the room was 22 degrees the whole time. Right? It kind of fluctuates a degree or two, and so this whole model is a little bit, it's a guess, right? It's an approximation. So, to get a number out of this, can you guys get me a number?
Yeah. 2.9.
It is 2.9?
Wait,
Oh yeah, the whole thing, everything
What do you-
together is 2.9.
Everything put together is 2.9?
Yeah.
how did you get 2.9?
Well, 'cause
How'd I
you
get
have- you have to
2.9?
Do the log rules and then do log.
Oh.
Natural log of 7.
Don't bother with the log rules.
Okay, yeah, 'cause I did that.
Just plug 7/15 into the logarithm
That's where I
function,
messed up, 'cause I
and
did
then
the
multiply
log
by this
rule.
thing.
Yeah.
If you do the log rules, which is fine,
Right. You just have to remember it in.
yeah, you have to remember.
That's what I did. Like, that's the wrong answer.
Right, so if you do the log rules, you need minus 3.8 whatever 065 times all
I'm still only
of
gonna
log
do 0.9.
7 minus log 15.
That's what I'm saying. I don't understand why.
Otherwise, you end up with a negative number.
Oh no,
And then negative x.
Well,
'cause you
negative time just
multiply
means a
that
go, right?
Times that.
It's 2.90.
But
You guys cool?
I got.
God damn it. Okay.
Where'd they get K? Such a good question. They calibrated their model.
5,
That's really what this K means. So the way you get K, traditionally, I think, for these guys, is you leave a pig cadaver out in a room. Dressed in a certain way, right? Because of course the insulation matters. Laying on a certain surface. So they've actually calibrated these models. And if you take like a forensics course, they'll have a table of Ks for varying degrees of dress and on what surface and immersed in how much water. So there's some super cool science there. Those Ks are experimentally found. And then you kind of play this matching game. Like this body is medium dressed on concrete. Yeah, so if the room temperature is changing, then you have to use a more complicated model. Like when you find a body outside, things are more complicated. But it's all there. There's a nice differential equation you can write down. Solving it's a little bit hard, but getting an approximate answer is pretty easy. Which is why you always hear this like, well, between the hours of blank and blank, right? And it gets worse as it gets longer, right? The reason it gets worse as it gets longer is, of course, this temperature gets closer to this temperature, right? And so you get to taking logs of 0. You guys see that? And once you're getting near logs of 0, things are getting really wobbly.
So that's 2.9.
Right, because as you're getting towards logs of 0, right, you're getting down in here. And so your error bars on your little measurement correspond to like enormo error bars on the output of that function.
So once like a body is room temperature, there's no way to
Yeah. Once a body's room temperature, then you move to something else. So you move to rigor or decomp or whatever. Yeah, I'm definitely not a forensics content expert. There are other things to move to at that stage. Cool? Awesome. Oh, the answer was, I should phrase this as a
2.9 hours. Oh,
as a sentence, right?
Victim's been dead for 2.9
Yeah.
hours.
Yeah, so dead for 2.9 hours. Right. Keep in mind when speaking with law enforcement, 4-letter words. No, I'm just kidding.